Hey guys, so this is 6D, which is graphs of sine and cos. It's something that you did last year, so hopefully some of the stuff, a lot of the stuff that I say right now isn't necessarily new and you remember what to do, so we can use it as a little bit of revision. With sine graphs as it says in this table, this is what they look like. That's the rule. Cos graphs, this is what they look like, and that's the rule. There's a few important things that we need to know though, which is your A value, your N value, and your K value, and what they actually do. It tells us what they do over here. So A is your amplitude, so that's how far up and down it would go from kind of your average, which is this part here. So K, which is this bit here, it tells us where that middle line is actually going to be. So if K was +1, instead of the middle being the x-axis here, it would be moved up 1 unit. It would be along there. Okay, so amplitude is always going to be a positive number, even though if we look at this sine graph, it goes up to 1, but also goes down to -1. The amplitude is just the positive number. So it's pretty much the distance from the center. So the distance from the center would be from here to here, which is 1 unit. And same from here to here, which is 1 unit. The other thing we need to know is the N value, which is in here, and that tells us the period. So the period is the length of each cycle. Now with these sine and cos graphs, they keep going. So even though we stop after one cycle, it's going to keep going like that. It's just not within our field of view, I guess. N's going to tell us how far each cycle is. Now we really need to remember this part here for sine and cos graphs, because if you look at that N value and tell me that that is what the period is, that's wrong. You need to use this to help to tell you what the period is. So you'd substitute that N value, whatever it is, into this little rule here, and that's going to tell you what the period is. Alright, so let's have a look at a couple of these. We won't do all of them, just a couple of them, just to make sure the video is not too long. As I said, we did do this last year. With a couple of these questions, you might see that there's some vertical shifts. So this one's been moved down 1 unit. With this chapter, or not chapter, exercise in the book, I don't think they actually use any vertical shift, because there's another exercise coming up where they introduce that, and then another exercise after that where they introduce horizontal shift. Okay, so this whole graph here might move however many units to the right or to the left, which we'll go over a little bit later. So firstly, we're sketching a sine graph here. We need to work out some important stuff. So we want to find out what the average is, or that middle line. We want to find out what the period is, and we want to find out what the amplitude is. So I think we should probably list all of those things, just to make it easier for you when you're sketching it pretty soon. So we can see that from this part here, our average is going to be at -1. We can see that our period is this A value at the front, which is 3, so our period is going to be 3. And the last, not the period, our amplitude, I should say. Got that wrong. And now the period. And to find the period, we need to look at this number here. So the period is 2 pi on n. Our n value is 2. So our period is pi. Now when we sketch this graph, it's told us to just sketch it for one cycle. First thing I should do is set that axis up. I'm just going to sketch it, the cycle that starts where x is 0. So here's my x-axis, here's my y-axis. Alright, now what I want you guys to do is kind of set yourself up a little grid that's going to show you exactly where your graph is supposed to fit inside, because if we're doing any vertical or horizontal shift, people get a little bit confused and start putting their lines in really wonky places. So it's a much better idea to put that grid in there to give you a bit of a guide as to where you need to draw each of these lines. So what I think we should start with every time is the average. So our average is at -1. So I'm going to put a little guideline along the line y equals -1. So along there. The next thing I need to look at is the amplitude. So it goes up 3 from that average, but it also goes down 3. If we go up 3, that's going to go up to +2, something like that. And if we go down 3, it's going to go down to -4. So again, I'm going to put a couple of little guidelines in. So our graph's never going to get above here, and it's never going to get below here. Alright, now the last thing we need to have a look at is the period. So our period was pi. So I'm going to say that this is pi. Now what I'd like you guys to do every single time you sketch these graphs is whatever the period is, break it into 4, because some kind of important points happen at each quarter of the cycle. So let's break this into quarters. So if that's pi, this is going to be half of pi. This would be a quarter of pi, 1 quarter, 2 quarters, 3 quarters of pi. There we go. Now I'll put those little intervals in. I want to make sure I have those little guidelines running vertically as well. Now this is in a reasonably small area, so it might look slightly messy. Okay. So we're set up. We should be able to draw a nice neat graph now. You don't necessarily have to do this kind of thing. I just suggest to do it because what I find is a lot of people muck it up, especially at the end of the graph, which I'll show you soon. So this is a sine graph. So that means it should start at your average. So it's going to start just here. Now with the sine graph, if it doesn't have a negative at the front of A, which this one doesn't, it's going to go up first. So it's going to have a little hill going up here, and we reach the maximum 1 quarter of the way through the cycle. The next thing that happens is we go down, and we get back to that average line halfway through the cycle. Then we're going down, we reach our minimum 3 quarters of the way through, and then we're going to go back up to the average. Now the reason, or one of the reasons why I put that grid line in, is what a lot of people do, particularly at the end of their cycle, instead of finishing at the average, they finish it at the x-axis here. So it would go, they would do this, which is wrong. You don't want that. So that's why you need to put those grid lines in. Okay, so let's have a go at the next one. Now this one here is a cos graph, which is a little bit different to a sine graph. As you can see, a cos graph is going to start up the top, then go all the way down to the bottom, and then come back up to the top again. So it's slightly different. Let's work out those 3 important things first. So the first thing is the average. We can see that there's no vertical shift because there isn't a +1 or +2 or minus whatever at the end here. So the average is just going to be on the x-axis. So the average is at 0. Pretty much the same as saying +0 at the end there. The next thing we want to have a look at is the amplitude. And hopefully we can see that the amplitude's always that A value out the front, so it's 1/2. So it's going to go up 1/2 from the average and down 1/2 from the average as well. The last thing we need to do is the period. So remember, it's 2 pi on n. And our n value is, it's not 3, it's actually 1/3, because x divided by 3 is the same as 1/3 times x. 1/3 is the coefficient. So it's 2 pi divided by 1/3. Now if you do that, it's going to end up being 6 pi. Alright, so the cycle for this one is a lot longer than the cycle of this one. Let me get my axis ready. Okay, so let's set up all those grid lines and stuff. So our average was at 0. The amplitude is 1/2, so it's going to go up 1/2 from 0. So that can be 1/2, and it's also going to go down 1/2 from 0. So -1/2. Put those guidelines in. And the last thing to look at is our period. So our period was 6 pi, so this can be 6 pi here. Remember, we need to break it into quarters. So halfway would be 3 pi. Here would be halfway between 0 and 3 pi. So that's 1.5 pi. 3 pi and 2. And halfway between 3 and 6 would be 4.5. So that's 9 pi on 2. There we go. So let's put our vertical guidelines in. There we go. Alright, so this is a cos graph. As we can see with the cos graph, it starts up the top. If it had a negative out the front, it would start down the bottom and go like that, except it doesn't. So we got the same shape as this one. So let's start at our maximum. Halfway through the graph, it's going to get to the minimum. But if we look over here, a quarter of the way is where that x-intercept's going to be. So just there. So we'll look something like that. And then we can see there's another x-intercept here, if we have a look at that. And it gets to the maximum right at the end. There we go, and we're done. Now we can easily identify what the y-intercept is, what the x-intercepts are for this one. This one might be a little bit harder. We can see that we've got an x-intercept here and an x-intercept here. That's something that we're going to work out in the next couple of exercises. So not necessarily this one. You don't need to find your x-intercepts if they're not at those kind of key points, so quarters of the way through the cycle, but that's something that we're going to work out soon. With these two here, have a go at those by yourself. I'm not going to do them right now because it's the same process as those two, and I don't want to make this video go for too long. Alright, so this is something that you didn't necessarily do last year. So it's talking about the transformations of your sine and cos graphs. It tells us about reflections and dilations here for each of them, so you can follow this grid. But I want to kind of think about it a little bit as well. So I want to focus more so on dilations. So it's telling us that from the x-axis, so dilation from the x-axis. If we look at, let's just go to these first ones. Dilation from the x-axis, that means we're going to be stretching this way, doesn't it? So if we're stretching up and down there, that's talking about our amplitude, isn't it? Okay, so if ever they're talking about dilation from the x-axis, we need to look at the amplitude. If we're looking at dilation this way, that's going to be period, isn't it? So dilation from the y-axis, we're talking about period. So let's have a go at these few here. Now sometimes when it gets a little bit hard, now one of these ones, this one is a little bit harder to kind of think about. So if you are finding it quite difficult, you can just use this kind of thing and just substitute your n value in there. But you'll see what I'm talking about when we do that example. Okay, so what we're doing is we are initially supposed to have the graph of just y equals cos x, but then we're translating it to gx. So they've given us different gx's here. Okay, so we're moving across to gx. All right, now this one here, we can see that this has an amplitude of 3. The initial one just had an amplitude of 1 there, didn't it? So we're going to be stretching from the x-axis, not 1, but 3 times what it was before. So we're dilating from x-axis by a factor 3. That's where I got that from. So I also want to look at the period as well, because as we can see, we now have a 2 inside there. So the period of this one would have been 2 pi. Let's see what the period of this one is. So 2 pi and 2, which means it is pi. So this one is actually squashed a little bit. The period of this one was 2 pi. The period of the new one is pi. So we're actually squashing it into half, aren't we? So we're going to have to dilate by a factor of 1/2. And if we're talking about period, which axis are we dilating away from? It's going to be the y. Sweet, let's have a go at the next one. Alright, so we're going from just cos x to this one here. I want to look at this part and see what that's doing. So this one has an amplitude of 1. This one has an amplitude of 1/2. So we're actually going to squash it down to half of what it was before. So that means we're going to dilate by